Hey guys, this is our
This is
awesome
our
quest
awesome
about
quest about
automatic
automatic
music
music
generation.
generation.
Hi, I'm Brody. Today the topics we're going to cover are explaining recursive neural networks and long short-term memory.
The vanishing and exploding problem of the recursive model. Brian didn't voice this one. Reading, understanding, and modifying music data.
In order to generate music, and before we start getting into deep learning, we need data, and we need to learn how to use the data. The best way to do an automatic music generation project is to use MIDI files, which stands for Musical Instrument Digital Interface. We use these because, unlike regular audio files like MP3s or WAVs, these don't contain actual audio data, and therefore are much smaller in size. They instead explain what notes are played, when they're played, and how loud or how long each note should be. This is essential to music generation because we are able to break down these files and gather the information into usable data. Luckily, through some research, we were able to find the perfect dataset. We found a dataset called Giant MIDI, which contains over 7,000 classical piano songs. The more songs you have, the more variety with notes and chords you have, which allows for better generated music pieces.
Now that we have our data set, let's begin coding. Our first import we use is called Music21, which is what we will be using to read MIDI files. We use Music21 to read the files and compile the individual notes and chords into arrays. We then store the information and distinguish the data to observe and understand it in detail, which is the number of unique notes. Then we're going to observe the unique notes and their frequency. We don't want to allow for too much top heaviness, so we can have more variety with frequency. Therefore, we create a threshold. We then create new musical files containing the notes with the more balanced frequencies.
Alright, that's enough talk from you, Brian. The next stop for our process is we need to read these new files we have created. And in order to do that, we need to assign each note with a unique integer to differentiate them. We then prepare these unique integers for outputs as well. Note: integers assigned to notes and chords are stored into sequences. This will be our data put into the final model.
Speaking of models, what model are we even using?
Well, I'm glad you asked. We are going to be utilizing a long short-term memory model.
Alright, to understand an LSTM model, we need to know what a recurrent neural network is. Essentially, a recurrent neural network is a network that can have multiple inputs of a piece of data at different times. These models are able to find trends in the data from pieces of information from the past in order to best predict the future outcome.
Hey, we have 7,000 songs in our data, and it looks like this model accesses the recurrent weight each time a new piece of data is put in. Wouldn't that end up multiplying by a number over 7,000 times?
Yes, exactly. This is the big problem with recurrent neural networks. We call this the vanishing exploding gradient. Vanishing if the multiplier is less than 1 because it becomes near 0. Exploding if the multiplier is greater than 1 because it becomes almost infinity. This is why LSTM exists. It solves the vanishing exploding gradient problem.
Long short-term memory fixes this problem by storing the long and short-term memory in two different paths. It chooses to forget some short-term memory and stores the rest into long-term memory. Keeping them both in separate locations is what solves the vanishing/exploding gradient problem.
Now here's what our project does. We have our modified music data, and we will now access an LSTM model using an import called Keras. This model is essentially taking in our modified music data as training data, passing it into an LSTM network, and giving predicted outcomes. It will give us the integers that it predicted, and then we will pass more of our music data as testing data to fully train the model. It will finally give us the last set of integers, which will be converted back into notes and chords and transferred into the final MIDI file. Now, let's have some fun. 3 of these piano MIDI files were created by real humans, and 1 of them was created by our model. You will have to guess which one it is. Good luck. Did you guess correctly? Well, if you did, make sure to give yourself a pat on the back. Anyways, that's the end of our awesome quest.